Today I'm going to be taking a look at this super noisy device. You know what, let's just go ahead and power this thing off before I really get into this. But this gives you an idea of how loud it's going to be. Anyway, this is a DECRU DataFort, and basically what this device is a huge encryption engine. And you would have this thing sitting between your big rack of servers and the network. And everything that you store on your big file servers goes through this thing and gets encrypted, and then anything you read off it gets decrypted. And the idea is that you can take the data that's on your big storage area network and store it off-site, knowing that it's safe because it's all scrambled. So the whole thing about this thing is that it's a hardened operating system with smart cards. As you can see, I got 2 of these smart cards which store the keys, and even has an emergency wipe button that you can configure to different degrees of paranoia. And on some models there's even a proper security key to prevent you from physically opening the device. There's a small display on the front, like a little status light, and the aforementioned destruction button, and just a smart card reader. There really isn't too much on this thing. There's a 2U unit which has an actual interface on the front, and it can, you can set it up on its own. I had to use a serial terminal to set this one up, and even when I set it up, it still doesn't seem to work properly, and it shuts off after a while. So I don't know what the deal is with this thing. I mean, it's not like I'm going to keep it, but it's a little weird that it's acting rather strangely. I actually got the software kit with it. It came with a CD, which is hilariously on a blank CDR, and like a burned CDR, which is ridiculous coming from a company that this thing's like $20,000 new. And I had the rack mount equipment, and it came all packaged in the original packaging, and just a couple of user guides on how to physically install the thing. I also got the little pack with 2 smart cards. These are labeled system. Now, one of the features of this thing is you can, this is called the crypto shred button, by the way. You can configure the crypto shred button to simply just stop all encryption and decryption, but you can also configure it to do things like completely delete the keys. So if, let's say, 2 board members of a big company, each one of them has one of these, you can define how many of these are required to unlock the device once it's been shredded. And you can have decisions based on how many are present. For example, if you wanted to wipe the device, you'd need a certain number of the cards present in order to approve it. Kind of like setting the auto-destruct in Star Trek.
Begin auto-destruct sequence. Authorization Picard 47 Alpha Tango.
Computer, Commander Beverly Crusher. Confirm auto-destruct sequence authorization Crusher 22 Beta Charlie.
Computer, Lieutenant Commander Worf. Confirm auto-destruct sequence. Authorization Worf 37 Gamma Echo.
Command authorization accepted. Awaiting final code to begin auto-destruct sequence.
This is Captain Jean-Luc Picard. Destruct sequence Alpha 1. 15 minutes silent countdown. Enable.
Self-destruct in 15 minutes. There will be no further audio warnings.
You can also set this up to just completely destroy the data the second you press the button. It will just destroy all the keys and everything. And that is actually kind of a scary thing when you think about it, because the only reason you'd ever have to do that is if there's like a physical attack on your building. Like, you could have a security guard who is sitting next to this thing, and his job is, if someone breaks into this bank or, government installation or whatever, he has to press the button and wipe the data at the last minute. So it's kind of a little unnerving when you think of just how this could end up being used in a real facility. So I'm going to try and turn this thing around, and we'll take a look at the back. I've already opened this thing up because it looked like the warranty seal was already broken, but it could have just been damaged. I'm not sure. On the back, we've got a pull-out power supply. This is a very large power supply rated at 500 watts, made by Emacs. I think I've actually seen this one. This was on another device. I think maybe the Riverbed Teardown. I can't remember which device exactly had these, but this thing gets very hot, and the whole system shutting off after a few minutes. So I don't know if there's actually a problem with anything, or if it's just waiting for some kind of response or setup, or it just restarts. So I don't know what's wrong with this thing, but it's definitely not happy. On the back we've got a serial, which it uses the like kind of Cisco style RJ45 connector, 2 network ports that are blocked off, and we've got a couple more network ports. This is the host side of the device, and this is the server side of the device. So this would plug into the networks, the storage server, and send out the encrypted data. This would communicate with everyone else. And if I look carefully in here, I can see that there's a regular motherboard in here. There's a VGA connector there, and this is the specific model number, the DataFort E515v2, with the lid off, which was just one screw and a warranty seal on this model. Like I said, there was a model that you could get an optional hardened security key and stuff for it, but this is just one screw. We can see that there's a single CPU here, some memory installed. Didn't even bother to fill up the whole thing on a freaking like $20,000 device. Got a Broadcom dual port Ethernet controller, a CF card running the operating system, 4 fans. Up at the top there's the smart card reader, and it looks like there's actually a SIM card reader as well. Over here is the real brains of the operation. This is a PCI encryption card. You can tell by the fact that it's all potted, and we're going to try and break into that because not only do they not want you to physically be able to open it, there's a intrusion detection switch here, but they also don't want you to physically be able to extract the data from the encryption card. Works similar to a credit card reader in that if you tamper with any of it physically, the encryption keys are stored in plain memory, so it requires battery power, and if you do anything, it will cut the power to the memory and destroy the keys. So just because, like, already, if this was actually initialized, which I couldn't do due to the software being weird, the keys would have destroyed themselves already, just because of the fact I opened up the case. And there's even a battery backup in here. I get a warning about the battery when I'm powering it on. Now, it said something about, like, you could set it up after you get the battery warning, so I don't know if that's just like it's just telling you that it's got a new battery or what, but yeah, I don't know, that battery could be dead. That could be why it's shutting off. The CF card in here is just a 1 gig industrial CF card, and I think I'm going to start pulling out all the boards so we can actually get a closer look at this thing. Okay, so I got a million screws out of this thing, and there's a million freaking wire ties on everything. This thing is just built like crazy. There's just, you can't go an inch of wire without there being ties on it. So yeah, I got all that out. It takes off the fan assembly, and they had a single heatsink, aluminum. What kind of crap is that? It's just copper plated at the bottom. Jeez, for the price of this thing, you'd think you'd get a full copper one. But under that is a single Intel Xeon. It's a 604 socket. It's actually one of the fastest ones available. It's 3.6 gigahertz with hyper-threading, 64-bit, 110 watts. That explains why the whole system was pulling 200 watts just sitting there. Ugh. Yeah, never going to use that. And they're not really worth anything, so yeah, probably just garbage. 4 sticks of ECC, 512 meg memory, so it had 2 gigs installed. I'm not going to power this thing up just because the design of the 604 socket means that these posts hold the CPUs in place, and the connectors on the back are covered up. So I can't get to the VGA port without cutting away the case, and that's just way too much trouble to see nothing, because it's just going to be a standard Intel motherboard BIOS, because that's what this is. It is just an Intel server board. So I'm taking this thing apart and I see this wire running off to the corner, and I'm like, what the hell is this for? It's just plugging in to the motherboard on the other side. Well, there's a teeny tiny hidden button here with a power icon, so I guess this is the power switch. It was turning on automatically when I'd power it up, but God, I would never have found that. There's also the little latch here to hold on to your IEC power connector. So this is common on a lot of rack mount systems where they don't want the power connector just popping out. So the front panel of the case just pops right off, and it's pretty basic. There's no real controls except for this crypto shred system, which we'll get into since the wire is plugged into the card. I'm going to show you that when I get to there, but it's just a little cover on this. It doesn't really do anything. This is the smart card input. Caution, pressing red button will delete keys. And there's also the LCD, which is just a basic LCD. It doesn't look like there's anything custom or fancy about it. It's just a regular 2-line LCD. There was this little LCD driver board. This connection went off to the encryption card. No, this went off to the display, power, and then this connection was off to the encryption card. And there's this like weird residue inside all the connectors. I don't know what the deal is with that. And there's some active circuitry on this, probably level shifting, because it's probably designed to let you hook up serial interfaces and stuff depending on which model it is. You know, it may have the model with the keypad cursor on the 2U unit, so they want you know, additional inputs and stuff. And there's a little LED there. That's the one providing the light on the front of the case. This is the CF reader. It simply says CF adapts whatever. It's a pretty basic ID to CF card adapter, although it is a rather nice quality one. It's got a real eject button on it, and apparently QC says it was okay. Mesa Electronics, and yeah, just a silicon drive, 1 gig. These are industrial flash cards. They're just basically regular CF cards that are, you know, warranted to crazy temperatures and stuff. 2009 manufacture date, 1 gig. This is the smart card reader, and you can see it says Gem Core 410 EMV. Now this is one of the smart cards that when I load up the software on my PC, it says, where's your smart card reader? Is this the one you're using? It's one of the ones in the list, made in France. Yeah, so this appears to be a serial smart card reader. Now I have the wire that was running along the board, and this plugged into the motherboard's COM port, and the other end plugs into this board. I can't remember where. I think it was under here. The power connector on this is kind of unique. It actually is a receptacle for one of the floppy drive style power connectors. I have never seen that before. I mean, I've seen the receptacles for it, but never an inline one like that. That's actually very neat. But yeah, most of the things on this board do... Oh god, these things are latching. I always forget that. Most of the items on this system run off these little mini connectors. This is just the power for the CPU, and there's a lot of cable, and we got a couple Molex, and the... Oh god, long cables, and the standard power connector. And I have to say, this case is just, like, the whole thing is just super clean. This thing definitely was brand new, because they said it was new. In fact, I haven't even gotten dirty. The only thing I've gotten on me is rubbing alcohol from cleaning the CPU, which makes your hands turn white. I don't know why. I don't know what the science is behind that. This is the other end of all the wiring, and it's got the connector for the power supply. It's not hot swappable since there's only one of them. And this just has like a little bit of caps and resistors on it, and there's a small board here that I think is just a watchdog timer to restart the board or restart the system if there's no power. Almost forgot the other side of the smart card reader. It actually has this SIM card adapter in here, and it's not used. There wasn't one in mine, and it's just got a couple bits of circuitry on here, and Atmel is probably just a custom, or one of their smart card cryptography chips. A lot of this thing is built with plastic screws, which is a little strange. Maybe they were having weird grounding issues or something, I'm not sure. But there's an awful lot of plastic screws. The CF card reader was held in with well, they're like nylon screws. Strange, you usually don't see them in computer cases too often. It's usually all metal. Long screws too. There we go. Okay. See. Okay, so there's a little module under here. Let me see if I can pop this off. This is pretty well put on. I don't want to open it up without breaking it, so I do want to try and interface this to the computer and see if the software will write to these smart cards, which by the way are Espresso Pro 64K FIPS, and they've got security domain V147 labeling, and they're both the same. Pretty standard if you've lived in Europe or Canada. You'd be used to this on your credit cards. Canada, at least Canada, has had them for like 10 years. This is the network card, but it's a basic Broadcom 64-bit PCI card. It says it was reworked. I don't see where it was reworked. Obviously there was some kind of manufacturing defect and they repaired it, but I don't know what. I don't see it. Yeah, it's just a basic 64-bit PCI card, and it's got like a neat surface mount heatsink on that, what is probably a voltage regulator, and dual port. Nothing fancy. It doesn't have relays or anything like that. One thing that I found really interesting about the case is all the fans connect to this one header, and then they just plug into the motherboard. I've never seen that in a case before. It's so organized, and they're all Delta brushless fans, 12 volts of course. Very nice, loud, but nice. There's an entire sea of freestanding MOSFETs on this motherboard powering the CPU. Now it's actually a dual CPU system, it just doesn't have two CPUs installed. And you can see that there's very lovely solid caps on it. I might try and take some of those off, although big boards are usually a pain in the ass to get the caps off. Another nice little touch is the platform controller hub, or Northbridge, whatever it is on this one, has a nice little shroud on it to get the airflow all nice and right on it. How cute. The motherboard has a basic Rage XL from ATI back when they were ATI before they became AMD, and more platform controller hub, memory controller stuff. This one has a lot of glare on it. I don't think I can really get a good angle on it. And over in the corner here, there is a WinBond chip, most likely the serial port controller. One thing I noticed is that there's this weird daughter card with an NXP ARM-based chip plugged into this high-density connector in the corner of the board. And I took a look at it, and it appears to be just a remote management card. A lot of server systems have this. My Supermicro boards have it, where it allows you to just do some remote management to the system on a hardware level. And I don't know if they even use it. It just happened to be installed. Cards plug into these two riser cards. Very standard in a 1U device, where you just have a 90-degree turn on your PCI cards. So the motherboard is an Intel server board SE7520JR2, and it also has these lovely Sanyo Oscom capacitors, which are top quality. Down in this corner of the board, there's the main power connector, and you've got all the connections for the fans, floppy drive for your. This is like a weird high-density floppy drive connector that I've never seen before. Parallel ATA, which is hooked up to the CF card. You got some serial ATA connectors that aren't used, and miscellaneous front panel and serial ports and stuff. Plus a lot of power supply stuff here in the corner. Big SMD capacitors. As I mentioned before, this is a 500 watt power supply, and I've seen inside these before. They're very well made and very compact. They have all these thermal transfer pads on them. Really want to get into these. It takes quite a while. You have to really start peeling away the case and stuff. Last but not least is the encryption card, which has this ribbon cable running off to the front panel LCD. It accepts power through a little Molex connector here, and there's a little connector here for the battery, which is a Rose Electronics 3.7 volt 400 milliamp hour lithium ion battery made in 2009. It's probably a pretty good battery. I'll try and check that out later. And there's a second connector that goes over here that splits into two. Well, it doesn't really split, it just runs off. These are actually in series. This is the chassis intrusion switch, and damn thermal compound from the power supply. And this is the crypto shred button. So the idea, like I said before, is if any of these are triggered, it can be programmed to do a certain thing, such as destroy all the keys or simply halt operation. And this just has a little thumb screw on it. It's weird that it's a locking switch. I find that strange, but I'm sure there's some reason for it. And moving along to the card, pull off all these connectors and stuff. The card is loaded with solid capacitors and these really nice Sanyo Oscon ones. And it looks like it's got a little bit of memory here. The main ASIC is underneath this heatsink that's been heavily potted. And there's obviously space for some kind of external interface because you've got these connector spots here, probably buffers, and a controller chip. My guess would be this is for a SCSI controller, because I do know they make models that interface between a computer system and a SCSI array. So this would take the SCSI data in, the controller would handle it, and it would encrypt it, and then send it back out to the array. And yeah, the rest is just power supply stuff, and it's potted on both sides, and there's this like glue on the edge, possibly to just keep it from separating. And there's a little battery in here, and that's it. Let's see if we can get into this thing. I really doubt we're going to make any progress. Yeah, that is really tough. I may have to soak that in paint thinner or something to get that open. I think we're just going to have to call it quits for today. I mean, I can get this little outer layer of glue off, but that doesn't do anything. It looks like the glue is placed before the epoxy, and it's acting as a mold, essentially, to keep all the hardened epoxy from, or the liquid epoxy from going everywhere. You can tell because the outside has a little lip to it, or texture. I was able to sort of dent it, but that's it. I don't think we're getting in here, so I'm gonna have to do that in another video. I'll probably just hang on to this, maybe take off these nice capacitors if I can get through the board. There's going to be a wire mesh in here that prevents you from breaking through. If you break through, it disconnects it. And I'd like to see the chip, but unfortunately I'm not getting in there. That heatsink, man, that's not going anywhere. My guess is it's an encryption chip made by Hyphen or something. I don't know if we'll ever know that. I'll try and get into it another day, but I'm not very confident.